Hey everybody, Mr. Bowman here. This is another video on 3.14 probability distributions. In particular, we're focusing on the only two merit questions from the 2022 exam. So just a reminder, all of these questions are the actual NZQA exam questions from that year. I've compiled them and put them all on the Quick Maths website. So check the link in the description if you want more of these questions to look at. So let's start off with question number 13. And this is a two-part question. We kind of needed I and double I to get the merit mark. So it is estimated for a New Zealand retail clothing company that 35% of the customers make a purchase. Using an appropriate distribution model, calculate an estimate for the probability that there is at least 3 out of 10 shoppers making so less than 3 out of 10 of the next shoppers entering the store. So this distribution, so I guess the first thing to note is we're dealing with kind of discrete data. So it's either they purchased something or they didn't. So you kind of like 2.5 people buying it. So if it's discrete data, it can only really be a percent distribution or a binomial distribution. Percent distributions require an average, which we're not given. We're given a probability. So that means we needing to use a binomial distribution. So let's always state down what distribution we're using. So we're going to be using a binomial distribution. And then following that, we're always going to state our parameters. So our probability of success, which is an individual shopper buying something, was 0.35. And my number of trials was 10 because I was asked for 3 out of the next 10 customers. So let's draw my number line. I always draw a number line for these types of questions. So 0, 4, 5, 6, 7, 8, 9, 10. So it said find the probability for less than 3. So less than 3 would be this chunk of people here, right? And it wouldn't include 3 because 3 is equal to 3. So what that means is for my normal distribution, so for my percent distribution, my x value is going to be 2, which is the upper limit of the area I'm investigating. So when I plug that all into my graphics calculator, I'm using the binomial cumulative distribution mode. The probability that x was less than 3, I got 0.2616, and that was a 4DP rounding. If you don't know how to use your graphics calculator to do that type of calculation, do let me know. I've got some videos I can send you away for extra help. So that was the answer to I. Now, moving on to II, it says to give two assumptions, basically. Key thing to note, it said to give the assumptions. We don't have to critique the assumptions. We don't have to discuss if they're good or bad assumptions. We don't have to discuss their effect. We just need to state them. So assumption number 1, and this is the go-to if you're never sure what assumption to state, one of them should always be something about independence. So it's always a good one, and probably 80-90% of the time you're going to get a mark if you successfully link it to context. So these 10 people coming in, we've assumed they're all independent from each other. So we're assuming there's no relationship between them all. It's all completely done at random whether or not they buy something or not. So that's the first one. So we have assumed, I probably should type this up at the same time, but can't be bothered. We've assumed that each shopper or each customer making a purchase when entering the store is independent of each other. Okay, so that's the first thing we're looking for, the first assumption. The second assumption, and this is kind of given to us in the facts of the question, is so in the question they've said the word estimated, which is not a good sign in probability. We like certainty, we like exact numbers. So we've assumed that the probability of a random person buying something is 35%, but that inevitably I think will change from day to day, person to person. So we've assumed that a random person has the probability of 35% of buying something, but that might not actually reflect the real world. So that's why it's an assumption, because it's a fact present in my calculations, but perhaps not present in the real world. So let's say to that, we have also assumed that there is a constant probability of 35% of each customer making a purchase, So that wraps up this question. So you did need both of them. I think if you got one kind of valid-ish assumption, you were able to get achieved, or if you just got the calculation, you got achieved. But if you had both components, you're able to get your merit mark for this question 13. Okay, we are now on to question number 14. So this carries on with kind of the customer shopping related theme that they had in the previous question. So management of a retail company has set targets for customers purchasing at least 4 items of clothing per 20 minutes in the store. Suppose that the number of items in the companies per store can be modeled by a percent distribution with a mean of 2.8. So that was kind of the lead up. The question we've got is, what value of lambda would be needed under a percent distribution so that at least 99% of the customers' purchase gets at least 1 item of clothing? So you see, this context here was related to 4 items of clothing, and that's why they give you the lambda. But now we're talking about at least 1 item of clothing, and for that we don't know the lambda. So this is actually an inverse percent distribution question. So let's start off by stating that. Gosh, they're not good writing it today. So inverse percent distribution. So I always state kind of the distribution, whether or not it's inverse or not, at the question, because every so often it requires you to get it, to do that for the mark. And we've been told, so at least 99%. So we've been told that the probability that x is greater or equal to 1 is equal to 0.99. So that means the probability of someone making 1 purchase, 2 purchases, 3 purchases, and so on, all of that combined gets you to 0.99. But the issue with inverse percent distribution questions is it only works when you know the probability of x when it is exactly to 0. Luckily for us, if you draw a bit of a number line, 0, 1, 2, 3, 4, 5, ... So we've kind of got this probability here, probability of 1 and everything above. So we can actually use the 1 minus p trick to find that probability of 0. So that means the probability of 0 is going to be 1 minus 0.99, which will be equal to 0.01, or 1% of the time it's okay for someone not to purchase anything during that 20-minute interval. So now that we've done that, we can then set up our inverse percent distribution question. So we know that the probability of x being equal to 0, for a percent distribution, that means e will be equal to the power of negative lambda. So that means 0.01 will be equal to e to the power of negative lambda. And this here, 13 stats, is not an algebra exam. You can just plug that straight into your graphics calculator to get the answer. If you don't know how to do that, let me know. I can provide you with a link that will support you with that. And when I did that earlier today, I got 4.6, and that there had a 1 decimal point rounding. So that means my average of 4.6 is needed to ensure that at least 99% of people purchased 1 or more item. So I now just need to explain what that actually means, because end of the day, this is a merit question. There's no context here. Merit questions always link back to context. So let's explain what that means. So I'm going to do that over here. So to be sure that 99% or more of the company's customers purchase at least 1 item of clothing. So at least 1 item of clothing lambda must be 4.6 items per 20 minutes or more. So it can actually be more than that, but 4.6 is the minimum that you needed. So that wraps up the 2 merit questions for this 2022 exam. It was pretty heavy on the achievement and excellence stuff. So hopefully you found them useful.